Okay, so when we graph these polynomials, there are a few things that we are going to need. We're going to need the zeros, and what I mean by zeros is your solutions for x. What is the value of x that makes that polynomial or that equation equal 0? Okay, and when we talk about those zeros, they are actually where the graph crosses the x-axis. Okay, so your solutions for x, the values of what x is equal to, is where your graph is going to touch on the x-axis. Okay, now luckily in all of these, it's already factored for me, so it's not going to be very difficult for me to find those zeros. So let's take a look at the first one. We have y equals, we have x plus 1 times x minus 1 times x minus 3. So when we are solving by factoring, once we get it factored, which it already is, we set each factor equal to 0 when we solve for x. So that's what we're going to start with. We're going to take that first 0, the x plus 1. We're going to set it equal to 0. And we're going to solve for x. That gives me one of my solutions. The solutions, they're called zeros. They're called roots. They're called intercepts. Okay, so a lot of things that you will hear them be called, you need to know that's just the value of x for this equation. When I set it equal to 0, what is x equal to? Then we have the second one is x minus 1. So we're going to take and set that one equal to 0. And we're going to solve it for x. And that gives me another 0 or another solution or another point where my graph is going to cross on the x-axis. And then the third one is x minus 3. So we're going to set that equal to 0, and we're going to solve that one for x as well. So I have 3 zeros. That means I have 3 places where my graph is going to touch the x-axis. So once I find my zeros, that's the very first thing we want to do, is we want to then put a point at each one of those values on our x-axis. So I need to put a point at -1 on my x-axis. I need to put a point at +1 on my x-axis, and I need to put a point at +3 on my x-axis. So again, -1, we're putting a point, +1, and +3. So that's the very first thing you want to do is find your zeros. Set each one of those factors equal to 0, solve for x, and then put a dot at each one of those values on your graph. So far, so good. Then the next thing it says that we're going to need is extra points, okay? Because I need to know in between each one of my zeros, in between each one of my x-intercepts, I need to know what my graph is doing. Which direction is it going to head? So I always start from the left side because we read from left to right. I have a point at -1 and I have a point at +1. What I need to do is I need to pick a point in between those. What's the easiest number or the only whole number to pick between -1 and +1? 0. So what we're going to do is we're going to choose our extra point by picking 0. Hold on. It's not working again. I'm trying to make it a little bit smaller so I have more room to... All right, there we go. Okay, so for my extra points, the first one I'm going to start with is 0. Okay, so if x equals 0, what I'm going to do to find the ordered pair, what the value is when x is 0, is I'm going to go back to the original equation. Everywhere there is an x, I'm going to plug in a 0, and I'm going to solve that for y. So my original equation is y equals, in parentheses, x plus 1, but I'm putting in a 0 in place of x. Then x minus 1, again, I'm putting in a 0 in place of x. And then x minus 3. So everywhere there is an x, I'm plugging in 0. Where did I get 0 from? It was the only point in between -1 and +1 on my graph. The only whole point anyway. I could have chosen a fraction if I wanted to, but those aren't nice to plug in. So try to keep them whole numbers. So what we need to do now is solve this for y. In my first parenthesis, 0 plus 1 is just 1. Second parenthesis, 0 minus 1 is -1. And third parenthesis, 0 minus 3 is -3. So if I multiply 1 times -1 times -3, what does that give me? +3. Okay. So the y value when x is equal to 0 is 3. So what I'm going to do is I'm going to plot that point. That's my first extra point. Okay, 0, 3. We're going to go put that on our graph. That tells me that in between the x-intercepts of -1 and +1, my graph is going to be, or a point of my graph is going to be higher. Now, because we have 3 zeros, the -1, the +1, and the +3, I got an extra point between these two. What I need to do now is get an extra point between these two. If this third point wasn't there, then the one extra point is enough, okay? So you're going to do one less extra point for how many x-intercepts you have. So I needed one in between -1 and +1, which we found was 0. What would be my number that I would want to choose between +1 and +3? 2. So we're going to do exactly the same thing, but this time we're going to plug in 2. Okay, I'm plugging in 2 everywhere there is an x so that I can solve for y. Again, going back to our original equation. Everywhere there's an x, we're putting in a 2. 2 plus 1 in my first parenthesis is 3. Maybe. 2 minus 1 is 1, and 2 minus 3 is -1. So what do I get if I multiply 3 times 1 times -1? -3. So the other extra point, that I'm going to plug in there is the point to -3. So I'm going to go to my graph and I'm going to put that point. Okay, so I found my zeros. I took each factor set equal to 0 solved. Then I found my extra points, the ones in between my intercepts. And then what I need to know is my end behavior. Okay, what is my graph doing on the left side and what is it doing on the right side? So with our end behavior, the quickest way that we can determine, first of all, what our exponent is and whether it's positive or negative is we just take the first, we take all of the x's, okay, that x and that x and that x. If I multiply those, if I do a positive x times a positive x times a positive x, what does it give me? It gives me a positive x to the third, okay? That's going to be the highest degree of that. I don't have to worry about multiplying everything out. If I just focus on multiplying the x's, that will tell me, is it positive and is it even or odd? What is this degree? Oh. It's odd, and then the number in front of it is positive or negative? Positive. So that is going to be like a positive sloped line, which means in this graph, my left side is going to go down, and my right side is going to go up, okay? Left side has to go down, right side has to go up because x times x times x is x to the third. That will give me my leading term. So then I'm going to go back to my graph. I'm going to go to the point on the far left, and I'm going to kind of, you don't want to go straight down, but you want to just kind of draw something at a diagonal down. That lets you know that your left side is going down. Then we're going to go to the far right point, the far right intercept, and we're going to go up on that one. Okay, again, not straight up, kind of diagonally. And then you basically just connect your dots, okay? Make sure you're curving through your points. You're not putting V shapes. Sometimes it's hard if you do your, okay. So it's going to look something like that. Try to curve through your points as best you can. Okay, you know that it's going down on the left, so you start from the down position, curve up to your points, and then it's up on the right. And that's kind of how you graph these. Find your zeros, pick some extra points, determine your end behavior, and then you have your graph. So I would like for you to take a few minutes and try number 2, please. Okay, with number 2, the first thing we want to do is find our zeros, our x-intercepts. So we're going to set each factor equal to 0, and we're going to solve to find where the graph crosses the x-axis. So I have the points -2, +1, and +3. So I'm going to put those, -2, +1, and +3. Then I need my extra points. Now, if we're looking at the left side of my graph, I have a point at -2, and then the next point isn't until +1, which means I could either plug in -1 or 0. It doesn't matter which one you plug in. I personally would probably choose 0 because it's easier. Did anybody else choose -1? Everybody choose, a couple people chose -1. Your graph is going to be very similar. It's just that one point will be a little bit off. That is okay though, because these are sketches of these graphs. They don't have to be perfect. When we do these, what I'm looking for is to make sure your zeros are correct, to make sure whatever you plugged in for your extra point is the correct value, and to make sure your end behavior is correct. That's what I'll be looking for. It's not going to have to be exactly like mine, okay, because sometimes they'll be a little bit different. If I multiply 2 times -1 times -3, I get a positive 6. So one of my extra points is going to be 0, 6. So I'm going to put that there. And then I have another point I need to choose in between 1 and 3. The only whole number there is 2. So I'm going to plug in 2 next. Okay. Yeah. Yeah, as soon as we're done with this, listen. You're welcome. All right, again, so I'm going to choose 2 because that is the only whole number in between 1 and 3. And plugging it back into my original equation. Two plus 2 is 4, 2 minus 1 is 1, 2 minus 3 is -1. So what value do I get there? -4. So plotting the point to -4. And the last thing I need is my end behavior. Remember, we're just focused on the x's. A positive x times a positive x times a positive x is going to give me a positive x to the third. So for end behavior, it is an odd exponent, which means it's going to be like a line. The number in front of it is positive, so it's going to be like a positive slope line. So my left side is going to go down, and my right side is going to go up. So I'm going to start in the down position on my left side. I'm going to curve through all of my points, and I'm going to end up in the up position on the right side. So your graph should look something similar to that. Is everybody okay with that? All right, try the last one if you hadn't already. Again, with number 3, what we're going to do is find our zeros first. This x in front is a factor, so it is going to be set equal to 0. So is the x plus 2, and so is the x minus 2. The only difference is when I set x equal to 0, there's nothing to solve for, so that's already one of my zeros for me. So it just kind of saves me a little bit of work. And then I solve the other 2. So I'm going to put a point at -2, I'm going to put a point at 0, and I'm going to put a point at +2. And you don't have to write extra points every time you work these out. I'm just writing it so you know what I'm doing. Okay. What is the point in between -2 and 0? -1. So we're going to plug in x equals -1 first. Everywhere there is an x, I'm putting a -1. So that gives me -1 times 1 times -3. What does that value give me? +3. So I'm going to put a point at -1, +3. And then I have to choose my second extra point, which is going to be in between 0 and 2. What's the only whole number I can choose there? 1. So we got y equals 1 times x plus 2 times x minus 2. So that's going to give me a +1 times a +3 times a -1, which gives me a value of -3. So I'm going to put a point at 1, -3. Got my zeros, got my extra points. Now I need to go back and look at my x's to find my end behavior. Again, I multiply the x's. It's a positive x times a positive x times a positive x, which is going to give me a positive x to the third, which is just like the first 2 we did. It's an odd exponent, a positive coefficient, so it's going to be like a positive slope line. So my left is going to go down, my right is going to go up, and I can now go back and draw my graph going on the down direction on the left side, curving through my points, ending in the up direction on the right side. And so your graph should look similar